So I'll get cracking. So yeah, thanks for registering and joining today's session. It's going to be on zero carbon buildings, the retrofit challenge. And yeah, it's really exciting to be discussing such an important topic today, especially with all that's going on around COP26 and all the discussions happening around decarbonisation. Retrofit of buildings is a really big priority. It's going to be really important in meeting our climate targets. And at the moment, we're sort of maybe a little bit slow on retrofit uptake. So it's really important that we boost this and kind of tackle some of the challenges that surround it. So just in terms of engaging with the discussion today, as is sort of a bit customary these days, I'm sure you're used to being muted as an attendee. We're not trying to silence you, but it just helps us manage the session. So if you do have any questions, please feel free to comment in the chat box. We'll leave time at the end of the session to kind of go through these questions. It's unlikely we'll pick them up as they come in, but yeah, do pop them in as you think of them. We'll be leaving about 20-15 minutes at the end of the session to cover those off. If you have any technical difficulties as well, Billy is on hand to help you out with those, so do pop them in the chat as well. And generally, our session will run with a couple of presentations from our expert speakers, and then a discussion at the end. So I'll just introduce our speakers now. It's great to be joined by them, and they're going to provide us with loads of insight today. So yeah, starting off with Neil, if you give us a wave. Neil is the campaign manager at climate charity Possible, and he leads on their heat decarbonisation projects, including Powering Parks, which is working with Abney Council to show how ground source heat pumps in parks can warm buildings using heat pumps. And he's also engaged in a new campaign to speak to the public and understand their opinions and thoughts about the transition to heat pumps in homes. So he's going to be talking a bit more about that later. Sarah Buchanan is the impact manager for Retrofit at Construction Scotland Innovation Centre. She's responsible for the outcomes within the Retrofit programme there and focuses on the affordable housing market, working as the strategic partner for the Scottish Federation of Housing Associations around low carbon design, energy efficiency, renewables, modern methods of construction and digital energy modelling. Welcome, Sarah. And finally, Martin Heath, who is the director and founder of Basingstoke Energy Services Cooperative. He's worked in the renewables industry for many years and is heavily involved in energy efficiency and renewables. The key activities of the energy cooperative are design, installation and maintenance of solar thermal, solar PV, battery and heat pump systems. So we've got a technical expert on the team as well. Great, so I think that's all from me for now. We're going to start with Martin, and he's going to talk to us a bit about what retrofit is and why it's really important, and discuss some of the technologies around it as well. So yeah, without further ado, I'll welcome Martin to the floor.
Thanks, Naomi. Yeah, we will run the technology, do a bit of screen sharing, and then we'll get on our way. So here we go. Hopefully you can all see that, guys. So that looks good. Yeah, I mean, really, I just wanted to spend 15-20 minutes talking about why retrofitting is so important, and how we're going to do it, and some of the, I suppose, some of the learnings, experiences we've had of retrofitting buildings, working with customers, working with clients, and getting them through a retrofitting process. So that's what I really wanted to cover. If I can then make the next slide work, which here it comes. Yeah, there's two organisations I work with. It's not just Basingstoke Energy Co-op, which is a true cooperative owned by its customers. I also work with an organisation called Your Energy Your Way, which is a community interest company, which tends to focus on the heat side. The cooperative tends to focus on the solar PV side. But enough of that. If you want to know any more, have a look at our websites, and I'm sure you'll find out much more than I can talk to in a couple of seconds. But I guess it's just sort of 6 things I really wanted to cover in the next 10-15 minutes about retrofitting. it's really about the main points are, it's about insulation, which is no surprises. It's about making our buildings far more energy efficient and far less leaky, so the energy we put in doesn't leak out rapidly. But I also wanted to cover two other important points. It's about ventilation and draft proofing, because a lot of energy, surprising amounts of energy, actually not leak through the fabric of the building, but mainly through leaks, through infiltration of cold air from the outside, or the leakage of hot air from the inside of a building to the outside of the building. So actually controlling airflow is incredibly important, but not just for heat loss and heat efficiency. It's equally important for wellness, well-being, and health as well. You need healthy air in a building, and actually trying to get an airtight building is not only impossible, it's not something you really want to do. So we've got to think about how we allow air in and air out as well, and to maintain the health of the building, and even more importantly, the health of its occupants. And of course, the other thing it needs to control is something called water vapor, which is produced just by us breathing and living in a house. And we want to get rid of that water vapor, because it doesn't do much good if it ends up in the wrong place. But I'll cover that. The other thing I wanted to cover is electrification. Is clearly how do we electrify heat, because once we've actually insulated a house, got our ventilation strategy in place, and made it as draft proof as you possibly can, then and only then is it time to replace the systems with an electric system, which is mainly heat pumps. In fact, it's almost exclusively heat pumps. I suppose the fifth point is we've got to consider the whole house. It's no point looking at one part of a house or a building and deal with that and ignore the rest. It's very much like squeezing a balloon. If you do just one bit thing in one place, the heat will leak out somewhere else. The other thing is, yeah, I've actually retrofitted my own house, so I know this from personal experience. It's hard, it's expensive, and it can be very disruptive, but that doesn't mean we shouldn't do it. There are ways we can make this whole process much simpler, much less expensive, and much less disruptive. But if I had to end my presentation now, it's basically what we need to do is reduce the energy input into a building by making it more efficient, and then once we've done that, replacing that energy input with a low carbon source. So that's retrofitting, I think, in a nutshell. But let me just go and dive into just a little bit more detail. You know, why should we bother, might be the next question. Well, yeah, it depends who you listen to and what numbers you look at, but a huge amount of our greenhouse gas emissions are down to buildings, particularly how they're constructed. Embodied carbon is actually a whole subject area in itself, and maybe there's another webinar and just on that. But the 45 to 50% of all the energy, and therefore all of the carbon emissions from a house, are in the operational stage. Yeah, this is the stage of a house when it's in its life, from its very first occupation to its eventual removal. So we're going to focus on the actual upfront operational carbon, you know, the carbon produced from a house whilst it's being lived in, and it is the biggest chunk of impact in carbon emissions. And lo and behold, most of that operational carbon is down to heating a building, particularly as we move into much more efficient white goods and lighting systems. It's a very simple model of a building. It's really not rocket science. You've got a building, and really you put energy in the form of burning fossil fuels or electricity, which hopefully is renewable. If we put more energy into a building than it gets out, the building heats up. If more energy it goes out than is coming in, it cools down. And when you have a balance of the two, the temperature stays very constant. And fundamentally, retrofitting is about managing those flows. So the energy comes in, and it'll either be lost through the fabric of the building, through the walls, the ceilings, the windows, which is a big chunk of the heat loss. Some of it might escape through water, hot water going down the drain, for instance, but that is actually a relatively small amount, and probably for the purposes of retrofitting, something that we don't really need to focus on. But the other major component is, as I said earlier on, is the air that leaks out of a building, i.e. the warm air that leaks out, or the cold air that infiltrates in. So these are the areas we really need to focus on. The energy out or the energy output really depends on how cold or warm it is outside, how much air is flowing in and flowing out, and how well the building is insulated. So, and how warm the building, the skin of the building is. So it's a very simplified model, but as I say, retrofitting is really a lot about understanding that, controlling that, and making sure we're making the building as efficient as possible. So I'd say, again, to make sure we don't run out of time, the steps are relatively straightforward. In my advice to anyone is, the very first thing you do to any building is insulate it. And once you've insulated, then you do a bit more insulation. And finally, when you've done that, do even more insulation, because that is fundamentally the best thing you can do with any building, is insulate it. Next thing to do is tackle the drafts and the air leaks, but don't look to make a building airtight. It's impossible and it's not desirable. And therefore you need to make sure you have a ventilation strategy in place. And once the building is relatively airtight, then maybe think about something called mechanical heat recovery, but only if the building is very airtight. Now, once you've got that all under control, you've effectively now controlled the amount of energy that's leaving the building. You've reduced it by maybe a factor of 50% or more if it's done well. Then it's time to think about putting in a renewable source of energy. And broadly, that really only comes down to two things. And we can probably talk about this in a little bit more detail. I know Neil's going to cover some of this as well. It's either individual heat pumps, which are put into an individual house, or it's a heat network, where a heat pump is providing heat in a centralized point, and then that heat is distributed around pipes to houses. But that's really all I wanted to cover, really. So they're the key steps. We really understand what the key issues are, and that's, I think, the 10 minutes I was allocated to talk about it. And hopefully it sort of raises some questions in people's minds, and we can have a good discussion about that in the next session. Okay, thanks.
Thanks, Martin. Yeah, just a quick question from me. In terms of the insulation piece, like, what kind of different insulation technologies do you think we should be using? Obviously, there's a whole range from loft insulation, draft excluders, things like that, very low cost, all the way to whole house kind of insulation measures. Like, what are you seeing people are asking for? What kind of things are you installing at the moment?
Well, yeah, and I think you touched upon them all there. I think the critical ones are loft insulation, because that tends to be the easiest thing to do, and the cheapest to put in place. But then once you've done lofts, getting into insulating walls can be relatively straightforward. But of course, there's the choice of whether do you insulate the inside of a wall or the outside of a wall. Insulating internally is slightly easier, but raises its own problems, because you lose space within a room. You have to lift all of the sockets and the light switches and a whole host of stuff like that. Or you can put it on the outside, and but that tends to be much more expensive, but a lot less disruptive. Insulating floors can be relatively straightforward if you have a suspended floor. So if you're in a more sort of older, sort of Victorian-like building with a suspended floor, then getting underneath the floor, which is dirty and not very pleasant, that you really can insulate the floor from the underneath upwards, or you can lift the floorboards and put insulation down. But there again, also controlling the water vapor is quite important to make sure that that's under control and you're not getting warm, damp air from the house getting into cold spaces, which then turns into condensation, which can be something it's something you really don't want, either as an individual, as a person, or as part of the building fabric. If you've got, my own house had a solid concrete slab, which is incredibly difficult to do, because you either have the choice of digging up the entire slab, which is incredibly disruptive and very expensive, or trying to lay insulation on top of the slab, which can be done. And I did it in my place, but again, that means raising light switches, sockets, and door heights, or you have a ceiling, of course. So there's various ways of doing it. But it's the thing to concentrate on first.
Yeah, definitely. And I think I would imagine people hearing about heat pumps, maybe they're spending a bit of money on those and possibly not thinking about energy efficiency first, and that's obviously going to like not make heat pumps sound like the most successful technology. So it's really important that we get that right, so that we don't kind of
because it's important. I mean, I did one of my local councillors said to me just the other day, he said, oh, when we have a fully renewable electricity, well, there's no point in insulating houses, we can have heat pumps.
Oh, really?
They can be run.
Oh dear.
And I sort of didn't have quite a sense of humour failure, but clearly energy is really expensive stuff, and the last thing we want to be doing is pumping really expensive, really valuable stuff into a leaky building. So ventilation and air tightness and ventilation are important regardless of how much energy it's come from low carbon sources. Yeah,
and obviously lots of co-benefits there for insulation on like reducing bills and creating a more pleasant environment. It's all a win-win.
It's the way to deal with things like fuel poverty and
for sure,
making houses much more healthy to live in, which is an equally important factor, quite honestly.
Yeah, definitely. Okay, thanks, Martin. If you could stop showing your screen now, we'll go over to Neil. I can see that we've got some questions through, so that's great. We'll come back to those. I'll make a note of those to come back to you later. So yeah, we're going to go to Neil now. He's going to talk a bit about what kind of the landscape is around retrofit, what's the government doing in industry, as well as the heat pump projects and heat network projects that Possible have been working on. Thanks a lot. Over to you, Neil.
Oh, thanks, Naomi. Yeah, hi, everyone. As Naomi said, I work for a climate change charity called Possible. So we run a number of campaigns and projects with the aim of inspiring more people to take more ambitious action on climate change. I'm going to talk. I think I've got about 15 minutes. Is that right, Naomi? I think so. Yeah, great. I'm going to talk briefly about a project that we did with Hackney Council, and that will also cover a little bit about how heat pumps work. I'll then talk a little bit about what the government is doing about heat decarbonisation and what's just been announced, and where there are gaps and what more is needed, and a little bit about what industry is doing, but I'll only touch on that because I think Sarah will cover that much better than I will. So first of all, I'll start with our Power in Parks project. So this is was 2-year project that we've been running roughly over the past 3 years. It's been a funny one this last year, as you can imagine. We've been working with Hackney Council and Scene. Scene are a community enterprise based in Edinburgh. They also have an office in London, and they did all the clever technical stuff on the project. So what we've been doing is we've been investigating installing heat pumps in parks to provide low carbon heat to nearby buildings. And that will hopefully help tackle climate change, as well as improving local air quality, and potentially also creating a little bit of income for the park managers or the council, whoever that might be. So we looked at all the data for parks and green spaces in Hackney. And we considered lots of factors. We drew data from Geological Survey and all the kind of like the council archives, and drew this into a shortlist of 10 locations that we thought would be ideal sites for heat pumps in parks, because they're a great site, but also there's a good demand nearby. So it could be a school or a council building or a leisure centre, that kind of thing. And we presented these findings to Hackney. And then we were really pleased that 2 of these projects got funding and got the nod ahead and are going ahead. So I'll talk a bit about those a bit later on. But I thought it might be a good idea to just start with, I think I've got a little delay on my slide. Let me just check. I thought I'd just start with a quick introduction of how heat pumps work. Hopefully you can see that on your screens. Yeah, brilliant. Thanks, Naomi. This is actually that you can see on the screen now. It's a ground source heat pump. This is the kind of thing we've been using in the parks in Hackney. But it all starts off with the sun. So the sun warms either the ground or the water or the air, and then a heat pump can then take that warmth and then concentrate it and pump it into buildings where it could be used to heat space and also for water. And also, interestingly, with some systems, not all, and probably not most of them that are most common in the UK, you can reverse that in the summer so that you can help to keep the building cool. But yeah, we can go into that a bit more detail if anyone has any questions about that. But as you can see on here, so a little bit about how this works, you see a ground array. That's right at the bottom. So this is only for a ground source, a ground source heat pump. For a water source heat pump, that ground array would be in the water. And for an air source heat pump, there would be no array. It just sucks in the air straight into the heat pump. But what you can see there, that collects the heat from below the surface of the ground. The array can be horizontal or it can be vertical. So that one there is kind of a horizontal one. This is a very simplified diagram, as you can imagine. And this, if you do like a horizontal installation, then that's quite good because you don't have to dig down very deep, but you do need a lot of space to put your coils in. Or you can just go down really deep and do a straight vertical borehole. But then that collects the heat from the ground. Now the white box that you can see in the middle there, that's the actual heat pump, and that can sit that'll usually sit on the outside of the building, or it might have its own little kind of covering as well, or a small building around it. The bit on the left hand side that says heating distribution system, that's just a posh way of saying your radiators and your hot water tank inside the building. So that's what's actually going to like warm the atmosphere inside. So heat pump works very much in the same way as a fridge, except instead of moving the warmth from the inside to the outside, it does the opposite. So it takes warmth from outside and moves it in. So you have a refrigerant, a liquid that's circulated around the sealed tubes of the system. And a compressor then changes the pressure of this refrigerant at different stages, which turns it into a gas and then back to a liquid. And if you remember from your science lessons, when things change from gas back to a liquid, that helps to absorb or release heat in the process of doing that. And the really clever thing about this is that for every unit of electricity that you give the heat pump to run this process, it can produce 3, 4, or sometimes, 5 units of heat, which makes it really, really efficient. For every 1 unit of electricity you put in, you're getting like 2, 3, 4 units of heat out. So that's what makes them really, really cool. Or hot. So in Hackney, so I said I'd talk a little bit more about these 2 projects. So this one here is Abney Park Cemetery. So it's a new development that's going ahead, it's an old cemetery site which has been turned into a park, and we initially discounted it as a source of ground source heat due to the presence of graves. So we didn't think there'd be space to put the coils or boreholes, but then we realized that there was a paved entrance area which had never been used. So we could use that part of it. So we're going to be putting 7 boreholes in there, and that would be enough heat to heat this new cafe and event space. And it'll save around 8 tons of carbon a year compared to using a gas boiler, which is what they were going to do initially. And that is only going to get cleaner and cleaner as the electricity grid continues to become more renewable and completely renewable by 2035. So it means that we're less dependent on fossil fuels, but more importantly, but another important point is that it's also not going to be contributing to local air pollution either. And a study that we did a couple of weeks ago that was out in The Guardian just showed how the number of gas boilers that we have in the UK is equivalent to double the amount of carbon pollution from all the gas power stations. So it's really a considerable amount. And it's not just the carbon emissions, it's also those nitrous oxides as well, which are really dangerous for our lungs. And these things are not emitting in far off industrial places. These are in the hearts of our towns and cities. So it's really also a really key point. And then the other site that we've had approval for in Hackney is actually for a water source heat pump, and this is the West Reservoir Centre. There's loads of potential there. So there is a converted water tower and filtration works, which now acts as an events space and for facilities for people who use the lake for swimming and sailing. So there's changing rooms and hot water for showers and that sort of thing. But from next year, they'll be heated by a water source heat pump. And we'll be using sunken heat collector there, which means no digging, and it also wouldn't have any implications for the use of the space either. So it's quite a straightforward installation compared to ground source. And another cool thing is that they have put some solar panels on the roof as well. So that's really improved the business case for us for the running costs, because we can use the electricity from the solar panels to power the heat pumps, which then give us the hot water and the warm air inside. So, that's a really nice situation. And then finally, what we did is we took all the learning from our project and we put it into into resource that other councils can use. So if you want your council to do something like we've been doing with Hackney, then there is a website on the slides there, and I think Naomi might be sharing these as well. Great. Or just get in touch with me and I'll let you know how you can get in touch with your council and share this. And also we did a study looking at all the parks and green spaces across the UK. Actually, it wasn't across the UK, it was just Great Britain, because we couldn't get the data for Northern Ireland. But it shows and breaks it down by local authority area of what the potential of parks and green space parks and green spaces have for harvesting heat for use in buildings across the 3 countries. And we found that the potential is around 30 gigawatts. That's about 10% of our total peak heat demand. So if we exploited all of that, it would avoid over 8 million tons of carbon each year, which is a lot. Probably wouldn't exploit all of that because it wouldn't be appropriate to use all that space. But yeah, that would be equivalent to about 2% of our total emissions. So really quite substantial there. I am going to move on quite swiftly because I don't want to run out of time here. I think I've got another 7-ish minutes. Is that about right? Yeah, I think so.
Good.
Great. So I'll just talk quickly about what the government are doing now to help progress our decarbonisation of heat, which is a very big task. And so this will be both for like schemes that we've been working on, so non-domestic schemes, and also our homes, which is a massive part of the problem. So about two weeks ago, the government released its very long-awaited heat and building strategy. We've been waiting for this for about 18 months now, but it's finally out with just under £4 billion of funding over the next 3 years, which does sound like a lot of money. But heat decarbonisation is a major challenge, and sadly it doesn't stack up. The amount of funding that they put forward doesn't really stack up to what's needed to get us to net zero by 2050, but there are positives in it and it is a start, so it's something that we can work from. So what was announced is we've got a boiler upgrade scheme. So that's £450 million of funding over the 3 years. It's a £5,000 grant, and that'll be provided to households towards an air source heat pump, or £6,000 if you're going for a ground source heat pump. The scope for that £450 million, so that would be roughly the equivalent of installing 30,000 heat pumps per year for the next 3 years, which is roughly about what we're doing already. So it's not a massive amount of ambition there. So we would like to see quite a bit more on that in a minute. But there's also the Heat Networks Transformation Programme. So as Martin was talking about, Heat Networks is that other option. So especially for people who are living in more built up areas, in tower blocks, where it'd be more appropriate to generate the heat more centrally and then distribute it to the individual properties. So there's £338 million of funding there. And that helps to help new and existing heat networks move towards low and zero carbon technologies. So heat pumps mostly, hopefully. And then there's the public sector decarbonisation schemes. So now this is what we use. So a predecessor to this is what we used in Hackney for the water source heat pump. But there's a new, $1.5 billion-ish amount of funding there to reduce carbon emissions from public buildings. That's mostly through energy efficiency and heat pumps. And we've got some funding also for low income and vulnerable households with a cost of installing low carbon measures and improving energy efficiency. So there's a social housing decarbonisation fund, £800 million there, and the home upgrade grant, which is 950 million. There's also an ambition to phase out gas boilers by 2035. That is a welcome move. Now, you probably saw Boris Johnson saying, you know, we're not going to be sending the Green Police around to rip people's boilers out. That's exactly what we're talking about when we are supporting this kind of phase out. It's because we don't need everyone to go out and get a heat pump tomorrow, but what we do need is for their next boiler to be a heat pump. And that's the important part. There's going to be a consultation on a market mechanism for heat pump deployment. So that's effectively going to be a mandate for boiler manufacturers to produce more heat pumps, a bit like they've done with electric vehicles. And the government's also pledged to look at the artificially inflated electricity bills. They bear almost all of the environmental levies, unlike gas bills. So it's really crucial that we make electric heat pumps more affordable to run. So rather than a quarter of your electric bill going towards the cost of decarbonising electricity grid over the last few decades, we think that burden should be shared, particularly since electricity is going to be the zero carbon and a cleaner option out of the two. So yeah, there is that ambition there to rebalance levies of the next decade, but it really needs to happen sooner. You know, we don't really have 10 years to wait for that. But green homes do remain severely underfunded. The commitments are really short of the manifesto commitments, and they're way behind what's needed for net zero. So there's still no funding or incentives for energy efficiency for the vast majority of households, those owner occupiers. So that's 60% of our properties. There's nothing there to help us with install all that insulation that Martin was talking about, and it's like so important, especially if we're going to be deploying all these heat pumps. And the funding that has been announced, it's still 2 billion short of the Conservative manifesto commitments, and it's 10 billion short of what's needed to get us on track to net zero. That's according to the research that's been done by the Energy Efficiency Infrastructure Group, so a group of industry and policy people who've been scrutinising these plans. So they suggest that we need another 3.6 billion in energy efficiency subsidies and another like 4-ish billion for heat pumps over the next parliament. But we also need a major push on information for the general public and also protection for consumers, really important. People don't know, it's been in the news a lot recently, but still, you know, a lot of people have no idea what a heat pump is, never mind how it works, or what the implication of these targets are for their daily lives and you know, how it's going to affect their houses. So we need a really big push on information for the public, and also crucially protection for consumers. So we want to make sure that people you know, who are making this substantial investment are getting the a fair treatment by the people who are going to be installing it for them. So the government have announced a boost to the Simple Energy Advice helpline, but there's very little detail on what that will look like. But yeah, the Simple Energy Advice helpline, it is really good. I mean, there's lots of really good information on there, but you know, I'm not sure what the usage statistics are on it. You know, we need everybody to, you know, to have this information available. So we really need to have kind of like a one-stop shop, really, where people can go and get all the advice needed and point them in the right direction. This is what's going to happen when, all that kind of thing. I think I've run out of time. I was going to touch very quickly on what industry is doing, but I think Sarah is probably going to talk a bit more about this. But should I keep going for another 30 seconds or?
Yeah, go ahead.
Oh, okay, great.
Why not?
So you might have seen in the news recently, and it's really exciting that Octopus, the energy company, they're doing really exciting things. They've made some really impressive announcements recently. They're training up hundreds of new installers at their new centre in Slough. They've basically built this massive, they call it a shed, but it's more like a hangar, and they've built houses inside it. So it's like a 1970s house, and I think it's a 1980s house, maybe a 90s house. So the 1970s house, it's complete with the like olive green bathroom suite and everything. It's quite cool. So that's where they're going to be training hundreds of people over the next year. To take out gas boilers and replace them with heat pumps, and they've got big ambitions for rolling that out. So that's really exciting. They're aiming to streamline the process and bring the cost of an installation down to that of a gas boiler next year. Really waiting to see that. I think there's many people in the industry that are kind of like, how are you going to do that? But yeah, they seem very confident that they're going to do it. But that will be with the help of the boiler upgrade scheme grant. So that'd be the that'd be the £5,000 plus like, you know, £1,500 for the heat pump. So yeah, really worth keeping an eye out on that. And also on the kind of like the installers front, Heat Pump Association said that we need 50,000 installers to meet the 2030 goal. We've currently got 4,000 trade heat pump installers across the UK, I believe. But Heat Pump Association says that we've got capacity to train 40,000 installers a year, but they're not coming through the door. So what we really need to see is incentives to get these trainees in, and the cost of the course of the training program is about £500. So either grants or, you know, low interest loans, that sort of thing. That's kind of what's needed there. I'll leave it there. I'm sorry for overrunning. Right. Thank you, Naomi.
No, thanks. That's brought us really well onto what my next sort of section was going to be about, because it'd be great to bring Sarah in on that skills question, training question, because I know CSIC have been involved in that quite heavily. Great, thanks. We've had a lot of questions coming in, so thanks for that. A lot of them are more technical, so I think we'll come back to some of the technical questions and we'll talk about skills for a bit. So yeah, obviously there's a huge potential here to create good green jobs, and there's obviously maybe a little bit of a lag, as you mentioned, on the numbers of people that we have to train, and also the funding for training. So yeah, I don't know, Sarah, do you want to come in on what kind of initiatives that you're running at the moment to make sure that we just kind of grasp this opportunity?
Yeah, sure. So CSIC is lucky to have an innovation factory in Blantyre, just outside Glasgow. It's 35,000 square feet of innovation space. We've got a lot of equipment that construction industry partners can come and use, can trial, can use to build prototypes. And we've basically sectioned off an area in the factory. We've built 4 huge training rigs made up of different types of construction, different types of wall insulation, things that you typically might see when you're out on a site. And we're using that to train industry partners for free. It's been funded through a National Transition Training Programme. And we're training SMEs, joiners, plumbers. We've had a lot of housing associations come over, and it's training people. It's called our low carbon skills programme. We will be looking to kind of self-fund that once this period of funding comes to an end, but we've done passive house in practice, and we're now moving on to our retrofit training, and you can join up. It's completely free. And it's probably a programme that will get repeated, I would imagine, after this funding comes to an end. And the other great thing is we're also working with Skills Development Scotland and the CITB in Scotland. So we will be making retrofit skills as part of the curriculum. So it'll be starting kind of early, that this is embedded into the skills that are getting taught at kind of college and university level. There are retrofit masters courses that are going to be taught in Scottish universities. And what's the great thing about the factory is it's the kind of practical skills. We haven't looked so much yet towards the heat pump technology, but that is definitely a course that we will probably end up offering, is some kind of installation course. So the biggest question for me is that there are skills training that is being done in this area, and we're not the only skills provider that do this in Scotland. In England, there's the Retrofit Academy, which is about trying to introduce the role of a retrofit coordinator. It follows the PAS 2060. So there's a lot of work getting done, but industry's not going to invest unless they think there's a pipeline of work there. There's not going to be a pipeline of work there unless we let the owner-occupier sector know that this change is coming and that they need to think about it. So for me, a lot of things can come together, but it's about the engagement piece. And I think we've touched on that today as well. But yeah, if anyone's interested in finding more about the skills programs, just get in touch.
Thanks, Sarah. Martin, do you want to come in a little bit on the whole skills training piece? We'll talk a bit more about engagement as well a bit later on. But yeah, from your experience, I guess how easy is it for you to find people to install?
I think it's one of the critical factors now. It's skills across the whole piece. Yeah, clearly we need a lot more installers of heat pumps, and significantly more than we've got now. And that does take quite a long time to train people to do that. I think the other thing though is, as we were talking about earlier, until you put the installation in and done the retrofitting, that's a place that really need to where the real skills shortages are. Now, find people who can understand building physics, so the engineers at one end of the chain, all the way through to technicians at the other end of that chain, who are skilled in understanding how buildings work and how you retrofit them, how you put in insulation. And as I've seen, one of the questions has already said, how do you control water vapor and condensation and actually make a house from being very cold and unhealthy to being very warm and healthy? There's a whole skill set there that we're not really beginning to see coming through our technical colleges or our universities. And we are going to need literally armies of people who can do this. And to give you sort of a rough idea, it may take 6 to 12 person days to install a heat pump. But if you're going through a deep retrofit, it may be 50 to 100 days of input required, person days. So you begin to see there's almost an order of magnitude more people required to do the retrofitting and the design of retrofitting as there is to do the heat pumps. But one doesn't work without the other. We've got to do both of them. And so skill shortages I'm beginning to see is one of the real critical things. In our own business, then basically we've almost shut up shop now and so we can't do any more installs of heat pumps until March next year. And that's not because of lack of demand, that's because of the lack of people to actually do the installs.
Interesting. Cool, thanks for that. I think it might be a good time to talk about the engagement piece. So obviously, the Green Homes grant was recently scrapped and had very low uptake from the public, from government, despite the multiple benefits that can be gained from doing these kind of measures. So what do you think needs to be done in order for homeowners and residents to embrace retrofit technologies? I'm going to come to Neil first on this, and then maybe the other panelists.
Yeah, sure. Yes, the government did say that they scrapped the Green Homes grant because of poor uptake. It's not true. So, yeah, the Green Homes grant did have lots of problems, but they weren't due to lack of public demand. Polling by ECIU actually showed that 2/3 of homeowners in England, well, 62%, were interested in the Green Homes grant, and there were 113,000 households that made applications. It was actually a very welcome scheme in theory. It was upfront funding for energy efficiency and low carbon heating, something that's been missing for years. And badly needed as well. But it was too short in scope and it was very poorly managed. So running of the scheme was given to an American contractor. So people who were like applying and having problems, they're having to call America, and with the time difference factor was not considered, unbelievably. And the application process was really confusing, it was complicated, and it caused no end of delays for homeowners. There were late payments to installers, which caused really difficult cash flow problems for a lot of companies. And there were some concerns over mispricing. Yeah, in essence, it was a good scheme. It just should have been delivered much better. So yeah, there's been a lot of criticism within Parliament for it as well. yeah, what we really need and what the public really need is properly funded long-term policies that are in line with the legally binding 2050 targets. And that needs real ambition, and that's including on public engagement with all the safeguards that are needed as well to protect consumers. Yeah, like, we need to make it easy for people, but we also really need to tell the positive story. You know, this is a great opportunity to turn our leaky, cold, damp houses, make them comfortable and healthy and warm. And you know, this is like a once in a generation opportunity to actually achieve this. It's, you know, it's really quite exciting. So we need to tell the positive story, get the public behind it, paint the positive picture, let people know, you know, what are their future homes going to look and feel like, and you know, really, yeah, needs to be a bit more research, and then a good bit of investment on this from the government too.
Thanks. Anyone else want to come in on that, Sarah? Did you have any opinions on the engagement side?
Yeah, there's a organisation in Scotland that we're going to engage with called TPAS, which is about tenant participation. We're basically going to try and learn from them to then take it to the owner-occupier sector, because a huge report's been done in Glasgow, and they've identified out of the 428,000 properties that need to be retrofitted up to band C, 70% are owner-occupied. And a lot of people, it's just not on their radars. Net zero is not even on their radars. So I do think that tenant engagement piece will be a big part of the work that we take forward for next year, and happy to keep people, you know, informed of what positive outcomes we get from it.
Great.
Yeah.
So
I'd add a little bit on there as well, and I think Neil's right. It's sort of two sides to the equation. From the government side, we need long-term policy. We can't just have short-term initiatives like the Green Home Grant, which could have worked really well, but you know, the whole industry had about a month's notice that it was going to happen, and we had to install 10,000 heat pumps in 3 months. Just, it's not going to work. It's good that the heat strategy is at least a 3-year program, which is giving us a little bit more certainty, which means we can start training people, can start investing in it. It would be much nicer if it was a 5-year policy or longer. So on the one hand, we'd certainly need that longer term, much more stable government policy. And on the home side, that engagement point is very important, is to help homeowners in particular to understand what this is all about. I mean, there needs to be a whole process of building knowledge within homeowners about insulation, about retrofitting, about heat pumps, because there's a dearth of knowledge there. And I can see from some of the questions coming through, you know, it's getting homeowners feeling comfortable with this and beginning to understand how this all works. And that again is another program of engagement that's required.
great, thanks. Yeah, I think we'll cover some of the more technical questions that we've had about heat pumps. I think there's a few that came in. So we had a question on what temperatures the heat pumps operate at, and is the heat stored anywhere for later use? And also what precautions are required on the powering park scheme to prevent exacerbating freezing ground conditions during winter? Do you want to, I don't know who wants to start on those.
Happy at the first shot, and others may yeah, heat pump can work all sorts of temperatures. You know, it's the classic temperature of a well-designed, well-installed heat pump is around about 50 degrees, 55 degrees, which is clearly much cooler than what a domestic boiler works at, but that's not a real problem. You can now get high temperature. We can get high temperature heat pumps that can work up to 70, 75 degrees. You know, at the moment, they tend to be a little bit more, a little bit less efficient. But as the science and the technology evolves, and we have different refrigerants in particular, high temperature heat pumps may become something that we use in more difficult to treat homes. You know, ones where you can't increase the radiator size, but a 50-degree heat into a radiator is absolutely fine, as long as the house is well insulated, you've got the ventilation and draft proofing under control, and you've worked out how you can change the radiator sizes if you need to. So yeah, heat pumps as a technology works really well, but it doesn't really matter what sort of heat source you put into a building, whether it's a gas boiler or a heat pump. If it's uninsulated and drafty, it's going to be expensive and not work. So it's not a heat pump issue, it's an insulation and draft proofing issue.
And then in terms of like older blocks with no space outside to put the heat pumps, Would you then recommend sort of a heat network approach?
I think this is a genuine issue that we need to get through. And if you look at a long street of, say, terraced homes, the current planning regulations for instance, say you can't put a heat pump within 1 metre of the boundary of your property. So if you're living in a terrace, that's going to be quite difficult. And they're not noisy, but if you had, say, 20 or 30 of them turning on all at the same time in a street, that might be a problem. So I think heat networks are going to play a big role in those, if you like, more difficult to treat, say, terraced houses where it's very difficult to find the space to put heat pumps. But then again, the answer is exactly what Neil's doing. It's heat networks with a centralized ground source heat pump or water source heat pump that's actually providing heat to the houses. And it works both ways, because heat networks don't tend to work in rural environments because you have to spend so much money on pipes and digging holes in grounds. But they really work well when there's very high heat density, i.e. lots of homes with lots of demand for heat. And so that's city centres and tower blocks and places like that. So it may be that heat pumps, individual heat pumps play a role in where there's less dense populations, and that could be in urban areas, out to rural areas, but heat networks play a big role in city centres.
Great, thanks. And Neil, on the powering parks question, is the ground going to be more frozen?
No, we're not planning on creating any unwanted ice rinks in Hackney, no. So yeah, a really badly designed ground source heat pump system, may go in that direction, but no, it's all about the design. So you make sure that it's properly spec'd for the scenario. We've been told that for the first year or two, you might expect a slight delay in grass cutting in the spring by about a week or two, but that should balance out over with time as well. And that in terms of recharging as well and the storage, with the sun does that mostly. So the sun recharges the ground. And it does reach a kind of equilibrium there.
Great. Yeah, no new ice rinks near me, but I will definitely be checking out some of those buildings that you mentioned because it's not too far. Okay, let's go to a question that on the kind of engagement thing again. So I can't remember who it was, but somebody said they're an interior designer and no one in the industry is talking about energy retrofitting. When properties are renovated or refurbished, it seems obvious that homeowners who are already engaged in this process of work on their homes need to be engaged in retrofitting. But from my perspective, I don't know where I can engage with suppliers who can come into these types of projects. How do you think that is a connection that's missing a little bit? And if so, how do we make the connections? I'm going to come to Sarah. We've got a couple minutes left.
Yeah, I actually answered that question by
Oh, you did?
No, it's fine. It's fine. Just
explain.
to let everybody know, the Retrofit Academy can give a list of all the certified retrofit coordinators, and that would be your first starting point for people. It's generally, it could be architects, it could be building engineers. There's lots of different people who go through the training, but they have a list of certified coordinators that can help with those types of projects, because it's so true. Everyone's getting their kitchen done now, their bathroom done now. Why aren't you thinking at the same time about some home energy measures while you're at it? So it's such a good point, and it makes so much sense. If you're going to be disrupting your house anyway, do it now while you're getting all this work done. So yeah, try the Retrofit Academy first. I'd say it's the first point of call.
That's definitely it's the upfront design is important. I mean, quite often we, for instance, get a brief from someone who's already, the designs have already been done, the layouts have already been done. Indeed, very often the work has already started. But if some of the heat pump installers and the installation guys were brought into the process much earlier on, we could design retrofitting in from day one. So there is a role, a big role for architects and the interior designers to begin to understand this, and then to engage with people further down the supply chain, if you like, the people who actually do the installation and the design work, and that's really critical. The other thing we've not really talked about, and it's probably also worth mentioning, retrofitting is not just going to be about climate change mitigation. There's a lot of adaptation that has to be going to be done to buildings as well. So it's not just about making them more energy efficient. And when we're going through these processes, we've got to start to think about how do we make these buildings far more adaptable to the new climates we're going to be seeing in 10, 15, well, even tomorrow for that matter. A lot more heavy rainfall, a lot hotter climates. And so we've got to start designing those sorts of things into houses at the same time.
Yeah, of course. Thanks so much for bringing that up. It's a really important point. Great. We could probably talk about this all day, and that would be amazing. And I'd love that, but we all have other work to be getting on with. So I just have to thank our three panelists, Neil, Sarah, and Martin, for joining me today and giving up their time to talk about this really important issue. I hope you've all enjoyed it. I'll be sending out the slides following this, and we'll also have a recording of this available if you want to share it with any friends and colleagues. So yeah, all that remains is to say thanks for joining, and yeah, have a great rest of the day.